This is a single phase dual converter kit. So here you remember this one is a one bridge P type converter and this one is N type converter. So these two P type and N type converters are anti-parallel only. Okay, so in between these two we have a load, so that load we are connecting across here RL load. Okay, and you remember here we have a triggering outputs. So P type converter having triggering outputs and N type converter having triggering outputs. Here we have a P type converter and N type converter, gate and as well as cathode. So gate is connected for P type converter. Here this one is a P type converter. Now in P type converter we have a 4 thyristors. For 4 thyristors here 4 gate terminals. So here mentioned TP1, TP4, TP2, TP3. For each and every TP1, TP2, TP3, TP4. So TP1 gate is connected for TP1 and cathode terminal is connected for cathode terminal. Okay, same like here also we have a TN3, TN4, TN1, TN2. Okay, N converter, gate and cathode terminals. Here this one is a gate terminal and cathode terminal. Here also mentioned TN1, TN4 and TN2, TN3. So each and every gate terminal and cathode terminal we are connecting here simply. And here we have a two lines. This one is one line and this one is another line. This one is one neutral point and this one is one neutral point. This line is connected here first P type converter line and this neutral point is connected for P type converter neutral point, and here bottom side one line is there, that line is connected for N type converter line and neutral is connected for N type neutral point. Okay, and here little bit confusion, it's very simple. Just you observe here, and there is data lines, in the sense there is no connection in between these two converters, so that's why I am going to convert one point between two converter, and same like bottom side also. Here also dotted lines are there, so it's mean there is no connection. That's why I have connected upside and downside. Okay, two converters, and from this P type converter also need to move the power supply to the load. So that's why I have taken this particular point to load, and as well as here also you remember this converter power supply also need to move the load side. That's why this particular point also I am going to connect from this particular point to load point. So this one is a load point. Okay, same like here also in bottom side also, from this point to this point and this point to this point. So this is the way of connection for single phase dual converter. Good morning students, our next experiment is single phase dual converter with RL loads. Okay, this is the actual circuit diagram. Single phase dual converter practical circuit diagram, this one. Okay, and this procedure, this one. This is actually output waveforms. Okay, so before going to do a experiment, first we need to know the basics of the dual converter. So dual converter means in a single phase dual converter, so we have a two sides anti-parallel thyristors. So here I have taken 4 thyristors. So those 4 thyristors are upside, but here I have taken 4 thyristors. Those 4 thyristors are completely anti-parallel of these 4 thyristors. So in between these two thyristors we are taking one load. So we need to measure this load is a RL load. So we are measuring the output voltage across this load. So that one is output voltage VO. But here you remember we are getting VO1 voltage by using this converter, and by using this converter we are getting V02 voltage. Okay, so this one is positive half cycle, in the sense we are getting this one for negative half cycle. So this one is alpha angle, and this one is for alpha 2 angle. Okay, here this one is a plus V01 voltage, and this one is a minus V02 voltage. Okay, so here we have a 4 quadrates, so in dual converter. So less than 90 degrees the dual converter is completely work as a rectifier, and more than 90 degrees the dual converter will work as a inverter. Okay, so these 4 quadrates are very important. If any case we are getting we are taking a firing angle is less than, firing angle is less than 90 degrees, that one is work as a rectifier. If we are taking firing angle is more than 90 degrees, then the dual converter is work as a inverter. Okay, then practically we are going to do the experiment here. The connections are very complicated connections here, but we can understand, then it will be a very easy to connect here. So here one line is connected for N type converter, another line is connected for P type converter, and N neutral wire is connected for N type converter, and another neutral is connected for P type converter. So here we have a firing angle variation. So we are connecting power supply here for a P type converter, line and neutral, and for the same time N converter also we have a line and neutral points. Okay, then I have taken here resistance and inductance in series, that one is a RL load. So here I have taken one CRO, then I am going to turn on the power supply. So you remember, before going to see the output waveforms, you remember here for V01 it's mean less than 90 degrees we are taking firing angle, then we are getting the output waveforms in rectifying mode. Okay, rectifying mode in the sense we are getting the output waveforms upside only we are getting the output waveforms. Okay, but we are going to connect, it's mean more than 90 degrees we are getting the output waveforms downside only. Okay, you remember here we got output waveforms downside. Why we are getting a downside, in the sense this one is a inverter. So inverter we are getting waveforms downside. So this one is a RL load, no? So that's why only we are getting excessive point also, because for negative half cycle also it will execute. It's mean inductor will not allow the sudden change of current. Because of that we are getting for a positive half cycle and a negative half cycle also it will get a little bit high extension of angle. Okay, then here you observe here more than 90 degrees only we got inverter. Then I am going to change the angle less than 90 degrees. I have taken 60 degrees. So you have observed here for a 60 degrees angle we got upside waveform. So upside waveform, in the sense this one is a rectifying. So already I said 4 quadrant, less than 90 degrees the inverter dual converter will work as a rectifier, and more than 90 degrees the dual converter will work as a inverter. So previously I have taken 150 degrees firing angle. For that we got waveform is bottom side, so that one is a inversion. And here I have taken firing angle is 60 degrees. For a 60 degrees firing angle we got waveform is upside, so this one is a rectifying, and as well as we are changing 150 in the sense we are getting negative side.